Hello, I'm Ming. The topic of my presentation is Convolutional Graph-tensor net for graph data completion. It is very likely to be accepted at the ETICA 2020 workshop. This work deals with the data completion problem in a graph structure. It uses deep neural networks to represent the general transforms of graph tensors. Outline. It has 6 parts: scenario and works, Graph-tensor model, problem formulation, solution, performance evaluation, and conclusion. Scenario. Nowadays, data with graph structures are common. The data constitutes a graph tensor. How to complete a graph tensor is an important problem. Later works. There are several solutions for this problem. For example, TNADMM and imputation algorithm. However, the current solutions have several disadvantages. For example, they need a large number of iterations, and they are time-consuming. We build models for this problem. We consider an undirected graph where each node has a data matrix. The graph Fourier transform and the inverse graph Fourier transform are defined as follows. To formulate this problem, we introduce the graph-tensor nuclear norm, GTN. The aim of this problem is to minimize the graph-tensor nuclear norm in the spectral domain under the observed data. We proposed our solution, Convolutional Graph-tensor net. It is ConvGTNet. It has 4 steps. Step 1, imputation. Step 2, general transform. It uses 1 fully connected layer, 2 convolution layers, and 1 ReLU activation layer. Step 3, soft thresholding operator. Step 4, inverse transform. It is the inverse version of step 2. The loss function has 2 parts: the fidelity of the reconstructed data and the accuracy of the inverse function. This figure shows the structure of ConvGTNet. We see that the upper part is the data flow. It has several phases. The bottom part is the detailed structure of one phase. There are 2 comparison algorithms, TNADMM and imputation algorithm. Experiment settings. ConvGTNet is trained in TensorFlow on a server with an NVIDIA Tesla V100 GPU. All algorithms are tested on a laptop with an i7 CPU and 15 GB memory. Dataset. Arrow Facebook dataset from SNAP. We pick 100 nodes and their corresponding edges to form a graph topology. Next, we show the performance evaluation. The first metric is completion accuracy with missing weight. In this figure, we see that the MSE of ConvGTNet is much lower than the other 2 algorithms. The second metric is the running time with missing weight. In this figure, we see that the running time of ConvGTNet is much lower than that of TNADMM, and the running speed of ConvGTNet is almost constant compared with imputation algorithm. This is because ConvGTNet has a fixed structure. However, in imputation algorithm, it needs more iterations to converge when the missing weight increases. Conclusion. We propose ConvGTNet to solve the graph-tensor completion problem using deep neural networks. ConvGTNet provides higher completion accuracy and runs faster than the other algorithms. Thank you.